Hello, my name is Tony Woods-Maya and my presentation is on network infrastructure. What does network infrastructure mean? Network infrastructure is the hardware and software resources of an entire network that enable network connectivity, communication, operations, and management of an enterprise network. It is typically part of the IT infrastructure found in most enterprise IT networks and environments. The entire network infrastructure is interconnected and can be used for internal communications, external communications, or both. An enterprise network, that's a private computer network built by a business to interconnect its various company sites, such as production sites, offices, and shops in order to share computer resources. Typically, a network infrastructure would include networking hardware, networking software, and network services. Network hardware is also known as network equipment or computer networking devices. They are the physical devices which are required for communication and interaction between devices on a computer network. Specifically, they mediate data in a computer network. Examples of network hardware would include routers, switches, LAN cards, wireless routers, and cables. Routers. This is a hardware device that routes data, hence the name, from a local area network LAN to another network connection. It connects networks of your infrastructure, enabling systems to communicate. An router acts like a coin sorting machine, allowing only authorized machines to connect to their computer system. Most routers also keep log files about the local network activity. Switches. A switch is used to network multiple computers together. It connects systems within a network. LAN cards. The LAN or the local area network card is a door to the network from a computer. Any type of network activity requires a LAN card. The internet, network printers, connecting computers together, and so on. Today, many devices contain a network card, including the Internet of Things, such as televisions for their internet apps, Blu-ray players, mobile phones, VoIP, desk phones, and even refrigerators. LAN cards are hardware devices that can be added to a computer, or they can be integrated into the main hardware of the computer. A wireless router is a device that enables wireless network packet forwarding and routing and serves as an access point in a local area network. It works much like a wired router, but replaces wires with wireless radio signals to communicate within and to the external network environment. It can function as a switch and as an internet router and access point. This is what regular people call Wi-Fi. And cables, for the purposes of our discussion, is the connection between your computer and your internet service provider. Network software is a foundational element for any network. It helps administrators deploy, manage, and monitor a network. Network software is not the same as software applications. Network software exposes the inner workings of the network to administrators, while software applications enable end users to perform specific tasks. Network software is invisible to the end users. Examples include network operations and management, operating systems, firewalls, network security, and operations. Network operations and management is one or more locations from which network monitoring and control or network management is exercised over a computer, telecommunications, or satellite network. Operation systems is a system software that manages computer hardware and software resources and provides common services for a computer program. Your firewall is a network security system, and it can either be hardware or software based. A firewall acts as a barrier between a trusted network and an untrusted network, such as the internet. Network security operations is an overarching term that describes the policies and procedures implemented by a network administrator to avoid and keep track of unauthorized access, exploitation, modification, or denial of the network and network resources. Network services is an application running at the network application level and above that provides data storage, manipulation, presentation, communication, or other capability which is often implemented using a client-server or peer-to-peer architecture based on application layer network protocols. Examples of your network services include your T1 line, a DSL, satellite, wireless protocols, and IP addressing. The T1 line is a dedicated transmission connection between a service provider and a client, and it uses an advanced telephone line to carry more data than a traditional standard analog line that carries a single channel of data at 64 kbps. Developed by AT&T Bell Laboratories in the late 1960s, a traditional T1 line used to be copper, but has since become fiber optical lines. T1 lines they use pulse code modulations, which allow coder and decoder sharing by multiple voice trunks. DSL is defined as the abbreviation that stands for Digital Subscriber Line, which is defined as a computer connects to the internet at high speeds using telephone lines. An example of a DSL is the phone service that might be down when your internet connection isn't working. Satellite relays telecommunication signals. Wireless communication uses electromagnetic waves to carry signals. These waves requires line of sight that are thus obstructed by the curvature of the Earth. The purpose of communication satellites is to relay the signal around the curve of the Earth, allowing communications between widely separated points. Communication satellites use a wide range of radio and microwave frequencies to avoid signal interference. Wireless protocols define the standards that allow networking devices to exchange information through airwaves, literally without wires. There are three main classes of wireless protocols. You have a long, medium, and short range. Long range is measured in miles, medium range is measured in tens or hundreds of feet, while short range is generally less than 10 feet. Each class has different protocols with varying attributes that make the selection dependent on the situation. And an example of a short range would be the Bluetooth devices that we utilize. Now, what is an IP address? Every machine on a network has a unique identifier, just as you would address a letter to send in the mail. Computers use the unique identifier to send data to specific computers on a network. Most networks today include all computers on the network. They use a TCP/IP protocol as a standard of how to communicate on the network. In the TCP/IP protocol, the unique identifier for a computer is called its IP address. There are two standards for IP addresses. There is the IVP4 version, which is what we currently use now, and then there's an IVP6 version. All computers with IP addresses with an IVP4 address, and many are starting to use, as I mentioned, the IVP6 address. The PV4 uses 32 binary bits to create a single unique address on the network, and each number is a decimal representation for an 8-digit binary number. And for the IVP6, it uses 128 binary bits, which is giving you more a greater number of IP addresses. When at the dawn of the IPv4 addressing, the internet was not the large commercial sensation that it is today, and most networks were private and closed off from other networks around the world. So having only 32 bits seemed like that would be sufficient, because that would provide just under 4.3 billion unique addresses. The IPv6 raises the panel from the 232 possible combinations that the IPv4 allows to 2,128 unique addresses. So other network infrastructure components, we have load balancers, storage area network, and DNS, which is a domain name system. Load balancers are utilized to distribute overall load on your web or application servers, or to distribute demand according to the kind of task to be performed. If you have multiple data centers, you should consider geographic load balancing. Geographic load balancing distributes loads according to the demand, site capacity, and the closest location to the user. If one center should go down, the geographic load balancer provides failover ability. Hardware load balancers would be installed in front of a server and behind routers because they direct routed traffic to the appropriate servers. Software load balancing solutions reside on the web servers themselves with software solutions. A storage area network are deployed so that the storage is independent of the servers that's used. And your domain name system are the internet equivalent of a phone book. They maintain a directory of domain names and translate them to IP addresses. So some emerging networking trends that I found are the SD-WAN, automation and orchestration, cloud networking, visibility, and analytics. The SD-WAN is a specific application of software-defined networking technology applied to a WAN connection, which are used to connect enterprise networks, including branch offices and data centers over large geographic distances. A wide area network might be used, for example, to connect branch offices to a central corporate network or to connect data centers separated by distance. In the past, these WAN connections often use technologies that are required special proprietary hardware. The SD-WAN movement seeks to move more network control into a cloud setting. Automation and orchestration. In most situations, cloud automation describes a task or function accomplished without human intervention, whereas cloud orchestration describes the arranging and coordination of automated tasks, ultimately resulting in a consolidated process or workflow. Visibility and analytics contain specific solutions for enterprises, data centers, and service providers that empower infrastructure architects, managers, and operators with unmatched visibility into the traffic traversing both the physical and the virtual networks without affecting the performance or stability of the production environments. These data access switches accommodate the growing number of network monitoring tools and network security tools. The benefits of this technology is that it filters unwanted data, it significantly improves tool efficiency and effectiveness, it reduces or eliminates configuration management and potentially lengthy changeover approval processes, and it secures your monitored data for security, compliance, and optimal performance. For discussion, I just want you to know if there's any trends that you would like to share with the group, and which do you believe would be more disruptive to the company, a hardware or software interruption, and how do you secure your entire network infrastructure? These are my references. Thank you so very much for watching my presentation, and I look forward to hearing your input. Thank you so very much.